Okay, this code looks decent. It's so enthusiastic, certainly. It's giving me a link to the XDC file, which doesn't exist. Please be right. What? No, this isn't gonna work. Hi everyone, and welcome back to my YouTube channel. In this video, we're going to be seeing if the robots are going to be taking over my job. I've actually been using ChatGPT a little bit for work, not for Verilog, for JavaScript, which is a whole other discussion. And I've been learning JavaScript for a side project. And I have been asking ChatGPT to give me help with my JavaScript. And I figured maybe we should see how well ChatGPT can write Verilog. So I am going to be looking at a couple of things. One is whether it makes sense, like whether it's syntactically correct. And then I'm also going to be looking at like whether it's good for beginners, like whether it is like good stylistically. And then I'm also going to be looking at whether it would work in hardware, because you can have something that's synthesizable, but is it going to be using simulation constructs or is it going to be making synthesizable code? And then I also want to see how it handles specific hardware. Like, yes, I can get it to flash LED, but will that do that on a Zibo board? Will it be able to give me constraints? Will it be able to, do all of the other infrastructure that's needed to put something in hardware? So those are the kinds of things I'm going to be looking at. It's a bit more complicated because obviously Verilog is it's a hardware description language. It's not a programming language. We are going to start with the very basic hello world of Verilog, which is flashing an LED. You need to interface your FPGA or microcontroller board with the LED. Okay, so it's giving me a 24-bit counter and it's counting up to 1,000,000. So what's the assumed clock rate? It's just saying 1,000,000. Okay, so looking at this code, we have an input clock, we have an output LED, we count up. When we count up to 1,000,000, then we toggle the LED and we reset. Okay, this code looks decent. I'm not complaining about that. The flash rate is going to depend on the clock rate, and it's outputting a register. Yeah, okay, this is pretty decent code as far as I can tell. It looks like it would work. Let's now get it to put it on a specific board. I want to see if it will find the right pin for me. LDO, LED output. I don't even know if that's correct. Okay, that's exactly the same code. That's exactly the same code. Okay, so this is assuming that it's giving me more. It's giving me more. Oh, it's giving me a top level port. Ooh, fancy. Okay. I was like, this is the same though. In this code, LED flash, the output is connected to the LED 0 LED. Does that even exist? Like, okay, it's also using 100 meg clock, but it's only counting up to 1,000,000. So that's actually going to flash really quickly. It's going to flash 100 times a second, or no, it's going to be on for 100th of a second and then off for 100th of a second. So that's actually a really fast flash. So I'm not super happy with that, but given that it's an AI, I'm okay. And it's also given me a top level module. I don't really know what it's aiming for with this. I want to ask for some constraints. I want to see if it will get the right port number, because this LD0 pin, okay, Zibo Z7, assuming you're using FIFO, which is a correct assumption. Okay, it's giving me 100 meg clock. Get ports. Oh, we've got L16. Okay, so let's check if L16 is indeed an LED port. Okay, that's not on here. Let us look at the reference manual to see whether it's correct or not. So if I look for GPIO, we can see here, here's the GPIO. It is correct that it's LD0. So it did get this right. Well done. But it's M14. So this L16 port is not the right port. If I look at the constraints, L16 is not an LED port. So if you are using this to get your PIN numbers correct, you are going to be woefully misguided because these aren't correct. I think this clock is the same. T10, I'm really curious to know where it gets these from. T10 is part of the P mod. So that's not a clock either. So these PIN numbers are not right. It's giving me a 10 meg clock. I wonder what the clock rate is on this board. Okay, so there's 125 meg reference. Oh, from the Ethernet. Okay, so that's the other thing, is that this clock rate is not right either. So there's 125 meg reference on K17. Takeaway, code is looking decent, but if you want to get it connected to hardware, you're going to have to do your due diligence on the constraints. That's fairly solid. We can flash LED. Why don't we make a FIFO? I'm not even defining the limits of the FIFO. And when it's okay. You can use the built-in fopen, fread, and fwrite. Oh wait, does this code actually? Okay, we've got a head or tail pointer. We've got some pointers, head, tail. Okay, so I was starting to get a bit worried because it said you can use the built-in fopen, fwrite, and fread functions to read and write data to a file. And then it proceeds to use none of those in the code, which is fun. Okay, I was worried for a moment because this would not be synthesizable. But then it proceeds to not use them at all and then gives me something completely different. This doesn't look so bad. It's chosen to make it 8 deep and 8 wide. And we've got write and read flags, we've got data in and out, and we've got empty and full. We've got a buffer. The way that a FIFO works, just to explain for the people who are not immediately familiar, is you have 2 pointers, a head and a tail, as it does here. When you write into the head spot and then you move the head pointer 1. When you read from the tail spot and you move the tail 1. And so the head and the tail follow each other through the FIFO, and both the head and the tail start at 0. So you write into the head at 0, and then the head increments to 1. And then when you read from the tail at 0, and then the tail increments to 1. If head and tail are the same, then it's empty. If head and tail are one after the other, then it's full. Like if the next head pointer is going to be the tail, then you've wrapped around. What I am seeing here is no overflow checking for the head and the tail. So head and tail just increment. If it's not full, then it just increments. But the depth is only 8. So what happens when the head gets to 8? The head should wrap around back to 0 at that point, and it's not. I want to see how it handles the overflow case, because this is going to overflow, so it's not going to work. If the head pointer exceeds the maximum index of the buffer, this is what we want, the FIFO will start to overwrite the oldest data in the buffer. Oh, okay, so it's relying on the fact that it's a power of 2. Okay, that's good. Okay, so it's relying on the fact that it's a power of 2. I want to see if it understands. There we go. Okay. So to create a FIFO with a depth that is not a power of 2, I want to see if it is going to understand that it needs to handle the head overflow case, because currently what it's doing is it is relying on the fact that the head and tail pointers are powers of 2. Okay, so it understood what I asked for when I said it must be not a power of 2, and it has now included a counter to keep track of the FIFO, and it has done overflow. So this is what I was looking for. Head equals depth minus 1. Overflow. This is what I was looking for. And now it's including a counter to keep track of the FIFO contents. This is pretty close to how I would have coded it myself. It didn't necessarily have to do the counter, I don't think. Just keeping track of full equals empty is probably good. I like this. This is pretty good. So I did have to prompt it in order to kind of get it to make it the way I would like it to be. But this is pretty good. I think that the fact that it was alluding to these fopen, fwrite, and fread is a little bit interesting. And then proceeds to never use them. But that's pretty decent. it seems like for the LED counter, at least it works. Like all of this code would work, but you're not going to get the exact same response every single time. I want to see if it can give me specific details about specific hardware. So I want to see if it can get me the right... Aha! Okay. So it's not gonna... Oh, it doesn't even give me a link. Oh my goodness. Can't you link to the reference manual? Do you have a link? Do you have a link to the reference manual? So it's interesting that it won't give me, if I ask for the specific pin number, it won't give me the specific pin number. But if I ask for the constraints, do you have the constraints for the Zibo Z7 board? So I can't ask for a specific pin number. That's really interesting. Okay, it's giving me a link to the XDC file, which it's the Z710 SDC. So it's a different link, which doesn't exist. That's helpful. Okay, that's helpful. It doesn't exist. I'm sorry, I'm finding that more hilarious than it should be. Does this one work? Yes, it does. Okay, so the takeaway is you can't ask it for pin numbers. If you ask it for constraints, it's hit or miss. So this constraints link doesn't work. And these constraints that it gave aren't right. So I think as soon as you get into the territory of figuring out pin numbers and hardware, you're gonna be on your own. So I want to make it do something a little bit harder, because this is pretty easy. And we're kind of getting a feel for what it can do and what it can't do. It can't do constraints, that's for sure. So I want to ask it to do something that it can mix up with simulation and synthesis. I wanted to ask this specifically because the synthesizable construct... Ooh, a recursive approach. Oh, dearie me. Oh, this is... Ow. Okay, this is not going to work. This is where, you see, I wanted to see if when I started asking it something a bit more complicated, whether it would handle it. Because the way this is working is it's obviously pulling from a repository of code. And obviously there are lots of Verilog LED flashing tutorials out there, and FIFOs. Like, both of those are relatively standard bread and butter Verilog implementations. However, when you get into these kinds of mathematical operations, like a log function, I wanted to see whether it used the built-in that is simulation only, or whether it went the way of doing it properly in Verilog or getting it wrong in Verilog. Because what it can do, which is what I think it's done here, is it's taken an algorithm that you would use in a programming language, like Python, and it's just straight applied it to Verilog. The reason why this won't work is because the signal X is being driven by itself shifted to the right one. And a signal can't be shifted. In a always block that doesn't have a clock in it, like this one does, you can't have a signal be driven by itself. It infers a latch. And the reason why is because you're basically creating a infinite loop where the signal is just being fed back onto itself around and round and round in circles. And you want to have a clocked element in there, like a register, like a clocked register in there, so that you can analyze the timing correctly. So otherwise it's just constantly going around in circles over and over again, and you can't analyze the length of that path. I'm not surprised. I'm trying to think what I can prompt to fix it. I want to see if it can give me correct code, because this is not going to work. Okay, I want to see if... There we go. Okay, synchronous always block. There we go. There, that's more like it. So now it's synchronous, which means now you can have the signal driving back onto itself. I need a valid. It's not giving me a valid. Okay. So now we've got it fixed. So the reason why we couldn't do this is because this didn't have a clock in it. And so this was inferring a latch. So we can fix that by putting a clock there. Now the signal is registered, so that's good. So that works. I need a valid though. Because I want to see, because this just goes around in circles continuously. And when x is less than 1, then it's done. But then it's setting y to 0, and y is supposed to be your answer. So I need to know when y is valid. You see, this is still not right though. This is not going to work. What? No, this isn't going to work. It's got the gist of it, but it's not right. I mean, it's there almost. Y is the answer, right? So as this loop goes around in circles, y is incrementing based on the number of bits that's in this number. So y is the answer. Y will carry on increasing while x is greater than 1. The problem comes where if I'm driving valid high here, I'm also driving y to 0 here. So y is always going to be 0 when valid is high, which doesn't make sense because it even says when x is less than 1, output y is set to 0 and valid is set to high. So that indicates the output is valid. So, but y is the output and y is 0. So that's not the correct answer. If you were a beginner and you used this code and you got it to this point, you would be, this is still not right. How can I prompt it to get it working? What I would do to fix this is I would have y, the output is driven by y here, and then the output is there. So you have an output signal, which is your answer there, and that point y, that signal is driven by that. Y temp, okay. Y temp is driven by x. Y temp. That's not what I was going for. Okay, wait, what did it think that I was asking for? Y temp output is that holds the intermediate value of x. No. It's so enthusiastic, certainly. Please be right. No! Oh. So close. Okay, I think I'm gonna give up. This line, this y temp equals, should be y temp is driven by y, and then this y temp output. Maybe I should just throw together an example so that we can all be put out of our misery. I'm going to copy and paste that original code. I will set up a project with this code to demonstrate why this doesn't work, and then I will fix it. I have been attempting to get the AI to fix it itself, but it's just, I'm not getting the right prompts. I think this is really interesting. This is a really interesting exercise. Let me just get my Vivado open. Okay, so I have set up a project using the example code that it made, and it's run into another issue because I realized, if we go back to this, that it's driving this X as an input, and then it's also driving this X. That's not going to work. Having X in and then driving it, it's not going to work either. We need an intermediate value for X as well. So this isn't even going to run. It's not even simulating. If I run simulation, it fails. And you can see here, procedural assignment to non-register X is not permitted. So it's not even, so I'm just going to quickly fix it by doing this. Okay, actually, hold on. Before I do that, let me give it a chance. I want to see if it will separate out the X input from the internal X value. Yes. Okay. Wait. No. This is turning into such an abomination. It was doing so well. And this isn't like an abomination. Oh, dear me. Okay. We can safely say the robots aren't taking over my job. Okay, this is not going to work. I was getting so excited about this X valid, but then I saw that it was continuing the algorithm within this X valid. What you need is X valid begin end, and then have all of this in the else. I'm giving up on this now. I'm gonna go through this and fix it. Okay, so what I've done is I've copied and pasted the code from here, this code, and then I also had to put an input register valid in X in and X valid and intermediate X signal. So I had to do that just to get it to simulate. Okay, so now we're simulating, and I put in an input value of 10, I think. So it should be giving me the log 2 of 10. So there's my input valid, and then my X register goes from 3 like that, and then my output valid Y is 1, 2. See, Y isn't initialized for one thing, so I'm just gonna like ignore that part. This is what I was trying to demonstrate. The Y valid is not at the right time. The Y valid is when Y is 0. That was what I was trying to demonstrate that was wrong with this, of which there are many things wrong. So let me just fix it. Okay, I got it to work. The valid still is not valid for as long, but there's my output value correct. So a couple of my takeaways. First off, you need to be able to evaluate the code yourself to decide if it works. If I'm a beginner and I know absolutely nothing about Verilog and I type in a prompt to do something that I want to do, I'm not going to be able to evaluate whether this is going to work. You can't just assume that the code that it's producing is going to work for you. It's hit and miss in terms of whether it will work, whether it'll synthesize, whether it'll simulate, whether the valid lines up with the input signal or the output signal. It does things like driving inputs with other values, which you can't do. It's not foolproof. If you're doing something really basic like these LED flashing, that's relatively easy because it's just taking one of the many examples of off the internet and just giving it to you in various forms. The FIFO even was okay once I prompted it to kind of get to the point that I liked, but I had to kind of prompt it to give it inputs to tweak it. And then the log2 function was just a disaster. So I definitely think that you need to be able to evaluate this code. It can be useful if you want a quick FIFO. It can be useful, but you need to be in a position where you can evaluate whether this is correct. And you need to be able to simulate or synthesize the code yourself and tweak it and work with it and not just take it at face value. So it's not taking my job anytime soon. It's also not going to be able to handle the hardware side of things like the constraints and working with the board files and stuff like that. I'm probably going to carry on trying to use it, but maybe in the future we'll do a state machine and see how it does with that. It's fairly interesting to see how it handles, where it's like reminiscent of correct code, but that's not really what you want. You don't just want reminiscent of correct code, you want actual correct code. So thank you for coming along with me on this wild ride of seeing how the ChatGPT does with Verilog, and I hope to see you in my next one. Bye.